translation here of axes. I started by drawing the parabola there, but I should clean it, I should start with just a clean sheet of paper instead of wasting my flip the paper. Translation of axes. That's what the topic is. Let's begin with the parabola. We said usually the parabola, if it looks something opening to the left or to the right, is going to be what? Y squared equals 4px. And if it opens up and down, it's going to be x squared equals what? 4py. But the center for all these problems was 0, 0, the origin. In this chapter, the center is no longer 0, 0. The center is going to be at h comma k, like with the circles. H goes with x, k goes with y. So now if we change the center to h comma k, this equation becomes, every time you see y, put y minus k. And every time you see x, put what? X minus h. This equation will be x minus h. H always goes with x. K always goes with y. So those are the equations I just showed you. I'll show in a few minutes how to use them. That's what the equation always minus h minus k.
Oh, that's the equation.
Yep. Now, for an ellipse, I can pull the notes from today's class. Where are they? I still have them here. That's the parabola still. All the questions. Where's the ellipse? The ellipse coming up. Here we go. Here's the equation for the ellipse. If it's horizontal, it's x squared over a squared plus y squared over b squared. So if it's horizontal like this, it's x squared over a squared plus y squared over b squared equals to 1. And if it's up and down, it's what? It's y squared over a squared plus x squared over b squared equals to 1. So now what happens if the center is not at 0, 0? If the center is somewhere here at h comma k, that's where the center is going to be. That equation will change. Again, h goes with x, k goes with y. X minus h squared plus y minus k squared over b squared equals to 1. And if it's up and down like this, it's y minus k squared over a squared plus x minus h squared over b squared equals to 1. So this center could be anywhere. It doesn't have to be 0, 0. If h and k are 0, 0, you end up with that equation. Now, let's look at, pull the notes out. Let me find, that's the ellipse, still the ellipse, ellipse. Where'd you go? Hyperbola. Here we go. We have the equation of a circle. We know what that is from before, but I'll put it there. Hyperbola there. We had it if it's pointing in the x direction. The equation is what? X squared over a squared minus y squared over b squared equals to 1. If the center is not at the origin, let's say the graph is like this, then it's x minus h squared over a squared minus y minus k squared over b squared is equal to 1. And if it's up and down, this will change to y minus k squared over a squared minus x minus h squared over b squared equals to 1. We know for circle we had that. That's never changed. X minus h squared plus y minus k squared equals r squared. That was the equation of a circle. So that's really all the equations in this chapter. We're going to be dealing where the center is no longer at 0, 0. So we have to figure out where the center and how to graph it. So now let me take some examples and see which one of these pictures I'm going to be using. So these are the equations. I took a snapshot of the nice clean ones, but this is my handwriting. Let's say we have this one, x minus 3 squared over 25 plus y plus 2 squared over 9 equals to 1. When you look at this, the first thing should come to your mind, well, that's either going to be an ellipse or a hyperbola, right? So which one is it, an ellipse or a hyperbola? Why ellipse? Because both signs are the same, positive. The bigger number is what? X. So it's along the x direction. It's an ellipse along the x direction. Except I'm not sure where the center is, you know? Where is it? So it's going to be an ellipse like this. Well, the center of that, based on the equation, it's always h comma k. Because the equation for that should be, when you compare to the standard form, x minus h squared over a squared plus y minus k squared. That's the form. So what is h equal to when you look at them? When you compare this to that? 3. And k is what? Negative 2. So my center here, 3 comma negative 2. This is my x and y axes. Yep. The center, 1, 2, 3, and negative 2. That's where the center is going to be. Well, I always tell people to make life easy on you is make a new, I'll get a pencil actually. Make a new axis here. Going through that center. If you make a new axis going through this point, and start graphing based on that new axis. So now a squared is what? It's 25, right? Which means a is plus or minus 5. You're going to go 5 to the right of this point. Notice not the origin, the new axis. 5 to the right. 1, 2, 3, 4, 5. So what's the vertex? What's the coordinates of that point now? Well, it's not 5. 8, not 0. 8, negative 2. Very good. Took us a few tries, but we got it. Go 5 to the left. 1, 2, 3, 4, 5. Minus 2, comma, minus 2. That's the other vertex.
Wow.
The y value, b squared equals what? 9. What's b equal to? plus or minus 3. Go 3 up, 1, 2, 3. Go 3 down, 1, 2, 3. And this is the graph I'm looking for. That's the graph, the ellipse that fits that equation. Still, the major axis still 10. That doesn't change. We just move the center. The minor axis is 2b, which is what? 6. And do a couple more examples on this, and that's the end of it. So all we're doing really extra is finding where the center is, shifting everything in that direction. That's what's called translation of axes. Let me try another one. X minus 1 squared over 4 minus y minus 2 squared over 9 equals to 1. Hyperbola, you're right. And which way is it opening? It's crossing the x-axis, right? So we know it's a hyperbola crossing the x-axis. But the center is not going to be a 0, 0. So the equation for that should be x minus h squared over a squared minus y minus k squared over b squared equals to 1. Where's the center? 1, comma 2. So here's my axes. 1 and 2. So there's the center right there. So now I'm going to make my axes going through that line. Here's a new axis now with the pencil. And I'll use the pencil, this one, as the axis or the center for my graph. Now, a squared equals what? 4. A equals plus or minus 2. You're going to go 2 to the right, and that's where my vertex is going to be. So the coordinates of that will be what? 3, 2, yes. And 1, 2 to the left. So this will be what? Negative 1, 2. Y squared, not y, b squared equals what? B equals plus or minus 3. Go 3 up and 3 down. 1, 2, 3. 1, 2, 3. And now let's make our box. So again, these are the asymptotes. And now my graph is going to go through that vertex. Shoot to the right. Shoot this way. Down this way. Up that way. Can we find what the focal points are? We need to find C. C equals plus or minus the square root of a squared plus b squared here. 4 plus 9, which is what?
13 squared.
13. So it's a little bit ugly now because it's going to be the square root of 13, which is what? A little bit more than 3.
Plus 1.
Plus the 1, yep, from here. So a little bit more than 3 from here. 1, 2, 3, a little bit more right here. So that focal point is going to be 1 plus the square root of 13, comma 0. Oh, I'm sorry, comma 2. Not 0, comma 2. Because that height.
Because you have 2.
This one's going to be 3 right here. 1 minus the square root of 13, comma 2.
Oh, it doesn't become.
Can't add them.
No, isn't negative?
It's 1 minus that number. It would be a negative because that's a negative 3 almost. So 1 minus 3, which is a negative 2. So eventually that number, if you do the calculation, will be a negative number. Like negative 2.1, negative 2.2, whatever. But that's my focal point. In this case, they will leave it like this because they're always looking for the exact answer. One more. Once you figure out this, it's not really like anything new. It's just continuation of what we did. X plus 3 squared equals negative 12 y minus 1. Notice, not both squared, only one. X the squared. That's either parabola opening upward or one opening down. Depends on P. I can see P is negative,
So it's opening down.
so it's going to be this one. So the standard form for this is going to be x minus h squared equals 4p y minus k. Center, negative 3 comma what? 1. Negative 1, 2, 3, and 1. That's my center, right there. Here's my pretend axes. Everything is crooked now. Yeah, there we go. Now, 4p equals what? Negative 12. P equals negative 3. It's opening to the left. So the focal point is going to be 1, 2, 3 to the left. That's where P is. That's the focal point. So if this is the origin, what is it? Right here. 1, 2, 3, 4, 5, 6. That's negative 6, comma 1, right? Now the directrix is going to be what? 3 units back from this. 1, 2, 3. What do you know? It's right here. So to graph it, what do we do? Go up, we said how many units from the focal point?
1.
Nope, twice that number of p. With the distance from here to there, 6. 1, 2, 3, 4, 5, 6. Go down 6. 1, 2, 3, 4, 5, 6. So your graph is going to look like this.
Very wide graph.
The vertex here, we know what the value, we said, what was it? Negative 3, comma 1. That's that point there. Again, why did we go up 6? Because you want the distance from here to the directrix to be the same. If that distance is 6, you want that to be 6. That's 6 units. That's 6 units. So we really just do one extra step, is identify where the center is, put a new axis there, then pretend you don't see the h and k after that, and graph them. And that's the end of the chapter, unless you have questions.